Assalamualaikum and good day. Today I will talk about my project which is Pe62, the Comparative Studies of Two-Switch Forward Converter in Renewable Energy Application. First of all, my name is Ahmad, my Hisham, my register number is 21092488. Alright, now the objective of the project. Number one is to design the DC to DC converter, which is two-switch forward converter and two-switch flyback converter. Number two, to compare the performance of two-switch forward converter and two-switch flyback converter in terms of efficiency and power loss distribution. And number three, to analyze the performance of both converter also in terms of efficiency and power loss distribution. Alright, now the project approach. The simulation of the converters. Number two is to analyze the converter on efficiency and power loss. And number three is compare each converter in terms of efficiency and power loss distribution. The tools that use is the PSIMs, simulations, and the auxiliary of Excel, Microsoft Excel. Right, now the tools description. How is PSIM working? Why the use of PSIM? The use of PSIM is to faster and more efficient than the general purpose simulation for power electronics. Number two, ideal for both academic research and industrial development. And number three, allows rapid prototyping of controls and power systems. The limitation of PSIM is thermal analysis in basic unless extended with additional modules. And number two, support control design, but it's not comprehensive as MATLABs or Simulix for complex control system analysis and advanced mathematical modeling. Right, now this is the interface of the PSIM simulation. There are file manager, components library, simulation setup, simulation interface, and also the ribbon. Right, now the demo. First one, start construct the circuit. All of the components can be obtained in components library. Number two, connect all the components based on the converter connections. Just now, this is the flyback converter with PV modules. And number three, insert all of the calculated and assumed parameters. Now the assumption is the MOSFET assumption and parameters. Number four, set up simulation controls and run the program. And last one, obtain the result from graphs and tables. Alright, now the result. The first one is graph from the simulation. After we run the simulations, then it will append the graph from the circuit. As you can see at the display, this is the two-switch forward converter graphs. Number two, from the graph, we do the data analysis to the Excel or from the Excel. Right now, there are two tables here, which is the junction temperature of the converters, and number two, the flyback converter, the output voltage of flyback converter, according to the difference power input voltage. And last one, the data analysis display in graphs. From the Excel, we extract the data and display it as graph to be more informative. Alright, now the conclusions. The single switch forward converter is simple in design and low cost. It also suitable for low to medium power application, and the efficiency decrease at higher power levels. For the flyback converter, it's ideal for low power applications. It provides galvanic isolations, simple and cost-effective design, less efficient, especially under higher loads. And for the two-switch forward converter and two-switch flyback converter, both offer better efficiency than single-switch variant. Them also reduce voltage stress on switches because it has two switches. And last one, it's more reliable for medium to high power application. Now that's all from me. Thank you very much for your attention.